Man, did you hear the other day? Energy is becoming less and less available to use.
Yeah, I heard about that. And our main source of energy, fossil fuels, are really bad for the environment.
No way!
Yeah, I know, that's crazy, right? If only there was something that we could use to produce energy while not harming the environment.
Wait a second. I have an idea.
What's the idea?
Let's go to the roof so we can try and use the sun.
How will we use the sun though? We need to absorb the energy somehow. Oh, actually, I heard about these things called solar panels, and I heard they're like little devices that can absorb the sunlight. I've never actually seen one before though. Want to go and check it out?
Yeah, let's go.
Man, what is this thing? All black and blue, and what are all these lines?
Man, I think these are solar panels, seeing as there's nothing else up here that could be anything like that, but it doesn't really look like it could absorb that much sunlight. I don't really buy it. How can something small and flat like this really absorb that much sunlight?
That's what I'm thinking. Wait, what's happening?
Wait, me too.
Why do I feel like this?
Me too. Oh
no!
Where are we? What is this place?
Bro, where are we? I'm lost.
Oh my god.
Hi guys,
Who are you?
I'm so Larry. Do you know where we are?
No.
We're inside of a PV cell. Do you know what a PV cell is?
No.
A PV cell is a tiny part of a much larger solar panel. Think of it like a little Lego piece inside of the much larger Lego set. So there's a lot of these and they all come together to make a solar panel. So we're on like a very, very, very small scale.
Wait, take it back a notch. So you're telling me we're actually inside of a real solar panel right now?
Yeah.
Oh my god.
That's crazy.
Do you guys know how solar panels work, right?
No.
Oh, do you want to learn?
Yes, Solar Larry.
Okay. This is silicon. This is the material that's inside of your phones. It's a semiconductor, which means it's good at conducting electricity, but it's not amazing. But it's very good for electronics, which is why it's used in phones and computers. So here, as you can see, there's two different layers. So the top layer here, this is called the positive layer, and the bottom layer is the negative layer. Think of it like a magnet, positive side and the negative side. In the middle here, you have what's called the depletion zone. So on the positive side, since it's positive, it means that there are less electrons. So it's a positively charged ion. So there's actually a bunch of holes here, right? And these holes are empty, and they want electrons in these holes, right? And at the bottom here, the holes are filled with electrons, but they actually have too many electrons. So these electrons here want to go into these holes over here. So what's happening in the middle here is you can see the electrons are actually going into the holes, and what this does, this creates a little electric field. Think of it like a tiny circuit, a tiny computer inside this whole silicon base. You might be thinking, well, you've said a lot about electrons and positive and negative, but like, what does this all mean? How does this connect to sunlight, and how does this produce electricity? Well, I'll explain. Here you have a photon. This photon is a particle of energy from the sun. So when the photon comes and hits the solar panel, the photon will come and it will knock out an electron. There you see you have an electron. It will knock out an electron from the negative layer, and this creates a chain effect where it knocks out an electron, and the electrons start spinning throughout the entire mechanism, the entire cell. And this creates an electrical charge, and this creates an electrical current. And this current is then transferred. You know the little lines on solar panels, right? Those lines that's actually conductive material that then takes the current and transfers it to wires, and then those wires connect to the electrical grid, and that's how you can power, you can power your fridge, you can power your electronics, you can power anything like that.
Whoa, that's really cool, Mr. Solari. Well, do you know anyone that actually knows anything about these solar panels so that we can see how it works? You explained it really well, but I feel like seeing it in person would help a lot.
I actually do. I have a good friend in Italy who has 2 solar panels at his house. So, well, why don't we let him explain it right now?
Okay, Antonio. Let's start. Those are the panel I just put her on recently, 1 and 2. So those are the panel who collect the sun. So they cut through the panel, they go, there's the light with the battery, inside there's a battery. The sun go through the panel, the power will go through the cable and charge the battery. Then the battery, when the battery is it's full, that system disconnect automatically. And then at night, on sunset, lights goes on automatically, and in the morning, as a sunrise is gonna go off. Those lights, they're good here for the last 10 years. So, and I would say about 10, 20 euro.
Avery, wait, since we're learning so much about solar panels and how they work, don't you think it's only fitting that we talk a little bit about the real world applications?
Yeah, you're right. And I came prepared. I did some research, and we can look it over together.
It says here that a standard 300 watts per hour solar panel produces around 2 kilowatts a day in average sunlight. That comes out to around 730 kilowatts of energy a year. But it also says here that an average household in Ontario uses about 8,000 to 10,000 kilowatts of electricity per year. That's a pretty big gap if you ask me.
Yeah, and that's why an average solar energy setup comes with arrays of multiple solar panels, since one isn't enough. One that produces around 7,500 kilowatts per year costs around $20,000 to set up.
Alright, let me punch the numbers into my calculator. That puts the cost at around 3 cents per kilowatt. That's not too shabby. That's a lot better than the $10 per kilowatt it used to cost back in 2000. I can't even imagine that. The cost has been decreasing by more than 7% pretty consistently per year, which is how we got to this point.
Apparently, only 15 to 20% of the energy absorbed by the panel from the sun is converted to energy, but researchers are working on technology that raises the efficiency up to 50%.
That's so cool. Imagine all the energy those panels are producing for the buildings and ground installations they're set up on.
Solar panels are used for things a lot simpler than that too. They can be used for things like traffic signs, radio transmitters, and even your handy-dandy calculator.
I heard there's a lot of other sustainable energy production methods too though. I wonder what makes solar panels better.
Well, for one, solar panels produce a lot less waste compared to the other popular production methods like nuclear and geothermal once it's set up.
The amount of water photovoltaic solar setups requires dramatically less than other sustainable methods too.
So does that mean that solar panel setups don't have any downsides?
Well, that isn't really realistic because unfortunately, solar panels require metals and silicon that need to be melted, which is a lot of energy spent. Also, they require specific treatment and procedures to be disposed of safely at the end of their lifespan.
So, Antonio, I hope you're satisfied about the video, and let me know, okay? This is the wood for the winter. Bye.
Thank you, Mr. Solari. We really learned a lot about solar panels today.
Yeah, your explanation was really descriptive, and your good friend really helped us understand the applications in person.
No problem, I'm always here to help.
We have to go now, though, so bye-bye.
Yeah, our parents are
Bye,
gonna
guys.
miss us. Bye.
Man, Mr. Solari really taught us a lot about the solar panels, but I searched it up because I was curious after we got back home, and apparently less than 1% of the energy we actually use in Ontario is generated from solar energy. How could this be when solar energy is such an efficient form of generating energy? I just don't get it.
That's really true. But you know what I heard? I heard that the government is actually expanding on programs so that homeowners can keep using solar energy more and more in the coming years until 2050. For example, the government of Ontario plans on giving tax returns of more and more monetary value to those who decide to sell their energy from solar panels back into power production.
Man, that's really promising to hear. This is all part of a plan from the government to reduce carbon emissions by 80% in 2050 so we can have a more promising future for our future generations and reduce our global footprint.
Thanks, Mr. Solari!